Okay, so these are 1.4 notes. Let's take a look at these. Number one, these are this is going to be for ratios and proportions, and sometimes we call this dimensional analysis. All right, it says consider the following nutrition facts for junior mints candies. Use the information on the label to answer the questions, including units in your work and final answers. Now, it's really important that we're talking about the units because, as I mentioned, that's the whole concept behind dimensional analysis as well as ratios and proportions. Keep in mind the nutrition labels tend to list approximate values. So be careful. Sometimes they're misleading. And percents are usually rounded to whole numbers. Okay, number one. We have, it asks us what percentage of calories in junior mints is from fat. Okay, well, we know that there is, calories from fat, 30. So we know that there's 30 calories from the fat, and we want to know the percentage. So we're going to divide that by the total number of calories, which is 170. Remember back in when you were learning proportions in pre-algebra, we had like a little formula for that. It was like part divided by whole. And that's all this is. The part is our calories from fat, and the whole is the 170 calories. Put that in, plug that into a calculator. Now, I know you're going to be using the TI-84 emulator in your Chromebooks. It's a good idea to get yourself a calculator, even a cheap one, to do these. It doesn't have to be scientific, just a 4-function calculator will do. Let's see, 30 divided by 170, and I'm getting 0.17. And if I want to turn that into a percentage, let's see, I'm going to round that up to, that's a 6, so I'm going to round that up to 18%. Remember, to make it a percentage, you multiply by 100, or in other words, just move the decimal over 2 places. And that gives me 18%. Okay, number 2. Let's see. This package of Junior Mints accounts for 5% of the total of the person's daily intake of fat for a 2,000 calorie diet. How is this number calculated? Well, I know that I'm having, this time we're looking for a percentage, so we need this fraction. I know that I have 3, the part, I'm going to use that part to whole again. I know that I have my 3 grams of part. Pen's not working. I know I've got my 3 grams of part, and my whole, now I'm looking at just the total fat, and I'm looking at the calorie diet here, 2,000 calorie diet, and I know that the total fat here is 55. And if I plug that into my calculator, I'm going to get 3 divided by 55. I get my 0.054, and if I use my decimal thing, that gives me about, I'm going to round that down because that's 4, so it gives me 5%. And that's how we got that 5%. Okay, number 3. what percent of a person's daily allowance of carbohydrates does she consume if she eats this whole package of Junior Mints? Find the answer on the label and show how to calculate it, assuming a 2,000 calorie diet. So again, we're going to use this 2,000 calorie diet over here. All right, so what percentage of carbohydrates? So this time, I'm going to look for my carbohydrates here, and I got 35 grams. And this time we're using the 2,000 calorie diet. So I look at 2,000 calories for carbohydrates, and I got 300 grams. And if I put that, let's see, we're looking for a percent. So I'm going to divide that out. 35 divided by 300. Enter. And I get 0.116. So if I round that off, I get 0.12. Move my decimal place over. Gives me 12%. Okay. You're going to go back and circle the answers. Okay. Number 4. Find the number of calories per piece of Junior Mint candy if there are 16 pieces in a serving. Okay. So this time it might be helpful here. And I think I'm going to do this first. It might be helpful to go ahead and figure out what the number of calories is per piece. Okay. So I know that I have a total of 170 calories per, and I think it says up here, 40 pieces. I know, I hope this recording comes out, might be a little blurry, but look at your note sheets. I got 40 pieces. So if I put that in my calculator, I'm going to get 4.25 calories per piece. Now, let's see. So that's per piece. If there are 16 pieces, well, all I'm going to do is multiply this by 16. So I'm going to take my 4.25 and multiply that by 16 to get my total calories, and I get 68 calories. And that's going to be for a 16-piece serving. Okay, number 5. Assume a person has a 25 calorie diet. What percent of his daily allowance of carbohydrates does he consume if he eats this whole package of Junior Mints? So I'm assuming that this package contains the 40 pieces. Round your answer to the nearest whole percent. Okay, again, this time my carbohydrate stays the same. We're at 35 grams, according to the label. But this time, I'm going to divide it by, let's see, for a 2,500 calorie diet, I've got carbohydrates, 375 this time. And put that in my calculator, and I'm going to get 0.093 repeating. Change it to, I think they want percentage. Yep. Move my decimal over twice. So that's approximately 9%. Okay, number 6. How many calories are there per gram of doing? Oh, we already did that. I did that to make number 4 easier. So that is 4.25 calories per piece. We got that from number 4. And number 7. The label says there are 30 calories from fat. How was that number calculated and how accurate is that? Well, let's see. To get this 30, just kind of reason this out a little bit. They've got, we're going to take the calories from fat. The label says it's 30 calories from fat. So I'm going to take the calories from fat. And then I'm going to divide it by the total calories. So it gives me 30 calories from fat, 170 total. And that gives me, let's see, 18 calories from fat. And it says, how was that number calculated? That's how I calculated it. I took calories from fat divided by total calories. How accurate is it? It's not very accurate. Because they told us there's 30 calories. They claimed there was 30 calories, so it's not accurate at all. So that's the first problem. Well, actually, first 7. Okay, next page. Now we're going to actually talk about ratios and proportion. You probably know this. A ratio is a comparison of two numbers and can be written in 3 different ways. For example, if the student-to-faculty ratio is a 40-to-1, it can be written, again, I'm gonna write this out a little bit. 40 colon to 1, that means that's a ratio, 40 to 1, or as a fraction, 40 per 1, or 40 to 1, or they could just write it out, 40 to 1. So there's the 3 ways. The quantities being compared in the ratio have different units. The ratio is called a rate. Okay, so this ratio is just a fraction. When it has different units, it's called a rate. By the way, if it has same units, it's called the scale, or no units at all. For example, the rate 30 miles per gallon is a comparison of 2 quantities, the miles to the gallon. It's perhaps easier to see this as a rate when it is written in fraction form, 30 miles per gallon. That dividing line is read per. Since the units, miles and gallons, are different, we refer to this ratio as a rate. So this ratio is a rate, and so on and so forth. Okay. Including units and ratio, help you decide the quantity should go numerator and which denominator. Really important when we get to ratios that you watch your labels. So don't ignore them. They're very important when you start setting up proportions. Proportions is just 2 ratios that equal each other. Suppose you have the cruise control on a long-term trip to 70 miles per hour. 70 miles per hour. I always use the fractions. I hardly ever use the other ones. Below are several interpretations of the rate, 70 miles per hour. Circle all the correct. And of course, this one's correct because I just told you. Okay. B, 70 miles every hour. Well, they're kind of playing with the English language here. That is true. You are traveling 70 miles for every hour here. So actually, this is a true statement. Let's see, 17 miles in 15 minutes. Okay, that's actually a quarter of an hour. So if I took my 70 and I multiplied that by a quarter of an hour, I'm going to use 0.25. I get 17 and a half miles. So this actually is correct. Okay, D, 70 miles. It doesn't say anything about hours. So that's incorrect. I'm not going to circle it. 315 miles after 4.5 hours. Again, let's see. That would be multiplying the hours by 4.5. I'm going to take that 70, multiply it by 4.5, and that's going to give me 315. So this actually is correct. And let's see, we travel 1 mile, and obviously not correct. Okay. Number 9. Common for recipes and mixtures to use the term part instead of a specific unit like cup or tablespoon. Okay, a part is any unit of volume such as teaspoon, cup, quart, gallon. The person who creates a mixture can choose the unit based on the amount being mixed. If we're mixing paint for a wall, a part could be a quart. If we're mixing paint for a canvas, a part could be a second squirt from a paint tube. Alright. A juice drink recipe calls for 3 parts orange juice and 2 parts pineapple. Below are several statements. Circle all that are correct. So again, all we're going to do is whatever unit of measure that we're going to put that and substitute it in for parts. For every cup of pineapple juice, you need 1.5 cups. So if I have, this is 1 cup. So if I have this 2 parts, it gives me the 1 part or 1 cup. If I have the 3 parts orange juice, that gives me 1.5 cups of orange. So this one's true. 1 cup, 1.5. It's half of this. For every 2 quarts of pineapple juice, you need 6 quarts of orange juice. Well, I can tell right away. These 2 match. 6 and 3 don't match. So that's incorrect. Yeah, I'm just going to put it next to it. When the juices are mixed together, the mixture is 3/5 orange juice. Okay, so let's see, I have a total of, because remember, this is that part to whole. Okay, orange juice, I do in fact have 3 parts. So my orange juice is 3 parts. My whole would be 5. And I do, so this one's true. The ratio of pineapple juice to orange juice is, now this time they want pineapple to orange, so it's going to be 2 to 3. So that's correct. If you have 15 ounces of orange juice, you need 10 ounces of pineapple. Okay, so to get 3 to 15, I got to multiply by 5. 5 times 3 is 15. 5 times 2 is going to be 10, so that one's correct. And F, if you use 4 cups of pineapple juice, so I'm going to multiply that by 2 to get 4, which means I'm going to have to multiply the 3 to get 6. But be careful, they're not asking for how many orange juice, they're asking for total. Okay, 4 cups of pineapple juice I'm going to have to mix it with, let's see, multiply by 2, 6 parts of orange to get 10 parts of total. Okay. Not 6. 6 is the amount of orange juice, not total. So this is incorrect. Again, you got to watch the wording. Okay, number 10. Number 10, they want us to use this label to answer the questions. Let's use a different color. Create a rate comparison suggested saturated fat grams to total calories in 2000. Simplify the fraction. Okay, so we have, let's see, saturated fat is, in 2000, is 20 grams. In a 2,000 part to whole, 2,000 calorie diet. They want us to reduce that. Easy way to do that on your calculator is we're going to take 20 grams divided by 2,000, hit enter, I get my 0.01. Now, they wanted to keep as a fraction, so I'm going to hit the math button, and then enter, and it actually gives me my fraction, 1/100th. And that was grams per calories. Okay, number 2, or B, I've got same thing. Saturated fat, but for 2,500. So, 20 saturated. I'm sorry. Oh, no, they give us a different amount. 25. 25, because I got to look at the 2,500 calorie. 25 grams, 2,500 total. That gives me, put that calculator. And again, I get 1 gram over 100 calories. Okay, compare your answers. What do you notice? They're pretty much exactly the same. Interpret the new simplified rate in words. Well, just because you increase the calories doesn't mean you change the rate. You shouldn't change the rate of saturated fat. So let's see. The rate of saturated fat shouldn't change with intake of calories. It should be maintained. Okay. Now, let's go on. Okay, now when two proportions, now we're going to talk about proportions. Again, it's a ratio that equals another ratio. That's a proportion. The easy pre-algebra way is you just cross-multiply it and solve for x. Remember that? The rates of 1 man for every 5 women, so 1 man for every 5 women, equals every 3 men for 15 women. Okay. It's a proportion. This is where we start getting into some of the dimensional analysis. Oh, here's that scale I was talking about. Let's hit that up first. Sometimes one ratio can be turned into another by simply scaling it. To scale a ratio, multiply or divide each quantity by the same non-zero number. If you can scale one ratio and turn it into another, then those two ratios are equivalent. Scaling a ratio creates equivalent fractions, kind of like simplifying fractions. Think of it as that concept when you're multiplying, dividing by scale. Okay. Let's do some of this dimensional analysis, but I'm not going to do it their way. I'm going to do it a little bit different. So, get a sheet of paper. Alright. It says, suppose you have hired for a job that pays $12 per hour. Is it true that you make 20 cents per minute? Okay, so let's do that one first. Okay, maybe I'll write it over here. This is, they're trying to use scales here, and there's an easy way to do all of these problems if you just use dimensional analysis. Okay, so we have, well, we get $12 per hour. I'm going to take $12 per 1 hour. And they're asking me to convert that to cents per minute. So I'm going to end up with cents per minute. Okay, now I can do anything to this fraction, multiply, divide, add, and subtract, as long as I do it by unit of 1. I'm sorry, just multiply and divide. So I'm going to actually multiply this fraction by unit 1. And I'm going to change this dollar to cents. Okay, so I'm going to multiply by a fraction, or just a unit of 1. Remember, just multiplying it by a unit of 1. Not changing the value of the fraction. I know that I want to get rid of that label. Okay. And we know that to get rid of things in fractions when we multiply, we can cancel out. I want to cancel out the dollars. As long as one's in the numerator and one's in the denominator, they'll cancel out. And I can only do it by a unit of 1. So I need cents up here. So I need to label cents in my numerator. This is kind of cool because my dollars will cancel out and I'll end up with cents. But remember, it's got to be a unit of 1. So I know that as a unit of 1, there's 100 cents in $1. That's a unit of 1. And that gives me, I end up with cents in the numerator. Okay. Denominator. I'm going to change from hours to minute. I know I'm going to have hours on top because I want them to cancel out, which means a unit of 1, and I want minutes on the bottom. And I know that there is 1 hour and 60 minutes. Again, a unit of 1. Okay, multiply all that out. 12 times 100 times 1 is 1,200 cents. And 60 minutes. 1 times 1 times 60. Now if I divide that out, 1,200 divided by 60, just reducing this fraction, I get 20, not changing my labels, cents per 1 minute. So, it is true. True. Okay, the second part. I'm going to do the same thing. And that's why I like doing dimensional analysis, because I can use the same concept over and over again and apply it to each problem. Okay. Is the equivalent to making $480 in a week with a 5-week, 8-hour shift? Okay, again, I'm going to start out with my $12. $12 per 1 hour. And let's see, I want to get to dollars per week. So I don't have to change the dollars, but I do have to change hours to week. Again, I'm going to pick my unit of 1. I want to get rid of hours, and I want to change it to, I think I'm going to, I could figure out how many hours in a week, but I know I'm going to go to days first, because I know there's 24 hours in one day, and I also know there's 5 days in 1 week. And when I look at it, I know that my hours are going to cancel, my days are going to cancel, and I end up with week on the bottom. Okay, so if I multiply 12 times 24 times 5, I get 480, and of course 1 times 1 is 1 week. Okay, let's talk a little bit about scalings. The scaling process shows that making $12 per hour is equivalent to making 20 cents per minute, or $480 for a week of 8-hour shifts. You can check 2 ratios by converting each to a decimal. And let's just go ahead and do some examples. This gets pretty wordy. Okay, 11